Future directions and challenges. Advances in LLM research. Model scale and efficiency. Future research in large language models, LLMs, aims to scale models to even larger sizes while improving computational efficiency. Techniques such as model distillation, sparse attention mechanisms, and parameter pruning can reduce the computational cost of training and inference without sacrificing performance. Multimodal and multilingual LLMs. Multimodal LLMs integrate text with other modalities such as images, audio, and video to enable more comprehensive understanding and generation of content. Multilingual LLMs can process and generate text in multiple languages, facilitating cross-lingual applications and improving accessibility to language technologies. Continual learning and lifelong learning. Continual learning techniques enable LLMs to adapt and learn incrementally from new data and experiences over time. Lifelong learning approaches allow LLMs to accumulate knowledge and skills across multiple tasks and domains, leading to more versatile and adaptive AI systems. Open challenges and opportunities. Ethical considerations and responsible AI. Addressing ethical challenges related to bias, fairness, privacy, and transparency remains a critical area of research and development in LLMs. Building ethical and responsible AI systems requires interdisciplinary collaboration, stakeholder engagement, and regulatory frameworks to ensure equitable and accountable deployment. Robustness and generalization. Improving the robustness and generalization capabilities of LLMs is an ongoing challenge, especially in handling noisy or adversarial inputs and out-of-distribution data. Techniques such as robust optimization, adversarial training, and domain adaptation can enhance model robustness and generalization performance. Interpretability and explainability. Enhancing the interpretability and explainability of LLMs is essential for building trust and understanding in AI systems. Research efforts focus on developing techniques to interpret model predictions, visualize internal representations, and provide explanations for model decisions. Sustainability and environmental impact. Large-scale training of LLMs consumes significant computational resources and energy, raising concerns about the environmental impact of AI research and development. Sustainable AI initiatives aim to reduce the carbon footprint of training models through energy-efficient hardware, optimized algorithms, and renewable energy sources. Collaboration and knowledge sharing. Collaboration among researchers, practitioners, policymakers, and industry stakeholders is crucial for advancing the field of LLMs and addressing complex societal challenges. Knowledge-sharing platforms, open-source initiatives, and collaborative research efforts promote innovation, transparency, and responsible AI development.